Kids, we are supposed to prove here that the square of an odd integer is 1 mod 8, which means a square of an odd number, if it is divided by 8, it should fetch me remainder 1. Now, since the primary focus is 8, so see, a number can be written in the form of 8k, or you can say 8k plus 1, or 8k plus 2, or 8k plus 3, or 8k plus 4, or 8k plus 5, 8k plus 6, or 8k plus 7, right? So a number can be written in this format. But please focus there. What they say is that the number is an odd integer, and since it's an odd integer, all the even number I should remove. All the even number I should remove. So I've removed all the even number. So I end up getting 8k plus 1, 8k plus 3, 8k plus 5, and 8k plus 7. Now kids, you all will agree if you just closely observe that 8k plus 1. So basically, if I write like this, so if I say x is equal to, it's 8k plus 1 means what? I can write this as x is equivalent to 1 mod 8. So if it's divided by it, the remainder is 1. Okay, just wait a minute. Yeah. Yeah. So it's 1 mod 8. So what will be this? This will be, if I talk about this will be what? 3 mod 8. So basically, from here it is 1, from here it is 3. Right? This will be what? 5 mod 8 because remainder is 5. And this will be 7 mod 8 because the remainder is 7. Right? But don't you think if 7 is the remainder if divided by 8, this is a positive remainder. So what will be the negative remainder? Of course, the negative remainder will be minus 1. Similarly, what will be 5 ka negative remainder? 5 ka negative remainder will be minus 3. So basically what the number becomes? So number x, which is an odd integer, is equivalent to, is basically congruent to plus minus 1 and plus minus 3 mod 8. So when you divide by 8, what happens? You get a remainder plus minus 1 and plus minus 9. Now what am I supposed to do? I am basically supposed to do the square of the odd number. So if I square this odd number, this will be congruent to what? It will be congruent to 1 and 9 mod 8. But again, can I say 9 is, it's a positive remainder. Even if I'm dividing 9 by 8, of course, what is the remainder again? Remainder will be 1 only. So I can say x square is congruent to 1 mod 8. So I proved here that the square of an odd number is congruent to 1 mod 8. This is one of the method, but if I want, I can have one more method. So let's call this is method 1. So let me show you one more method. So from method 2 perspective, actually, since it's an odd number, so let us say I say let x is equal to, it's an odd number, right? So I'll write this as 2k plus 1. Okay. Why? Because see, an even number is given as 2 times of k, 2 times of something. An odd number is 2k plus 1, or you can say 2k minus 1. So basically, of course, where k is an integer. So it's 2k plus 1. Now if I just square this, what do I get? I get 2k plus 1 the whole square. So x square comes out to be 4k square plus 4k plus 1. So x square is equal to, if I take 4k common from the first two terms, I get 4k into k plus 1 plus 1. Now if you closely observe, what you will find is that this is 4, that is fine. This is k and this is k plus 1. Now you tell me, If it is k into k plus 1, so this number has to be a multiple of 2. Why so? Because any two consecutive numbers ka multiplication is always an even number. Why? Because suppose k is an even number, then k plus 1 will be odd. And if k is odd, then k plus 1 will be even. So you tell me even into odd will be a multiple of 2 only, no? So basically I end up getting what? I end up getting x square is equal to 4 times, this is a multiple of 2, so it's 2 lambda, suppose, plus 1. So I get x square is equal to 8 lambda plus 1. Now x square, so ultimately it is nothing but 8 lambda plus 1. So can I straight away say x square is nothing but it is congruent to 1, because if I divide by 8, the remainder is 1. So it is x square equal to, is congruent to 8, is congruent to 1 mod 8. So if it is divided by 8, the remainder is 1.